Hi there, this is Mr. Cardoso, and in this video we're going to be looking at section 4.3, solving polynomial inequalities. And actually the good thing about looking at an example in this section is that it covers sections 4.1 as well, where we are just solving a polynomial, solving a polynomial equation. So that's the benefit of doing this. So here we have an inequality rather than an equation because there's a less than sign rather than an equal sign. So we have these two polynomials, one on each side. So what we're going to do, the first step is we have to bring everything over to one side. So we end up getting x cubed. And now if we put things in the order of the degree, we should go with the quadratic second. So minus 8x squared, as it comes over to the other side, it changes sign. And then minus 3x, and then plus 90 is less than 0. So the sign doesn't change there. And now we have something that we can see, obviously, that needs to be factored. Okay, so we need to factor this. Let's first try and see if there's a GCF, or greatest common factor, to take out of this. In which case, for the x's, there's no x here, so we can't take out any x's. And there's only a 1 here, so we can't take out any numbers. So GCF factoring fails, but always check that first, because that can make your problem a lot easier. Okay, so now it's time to use the factor theorem to find something that will make this equal to 0. So we're going to just factor this as if the right side of this is not here. We're going to take a look at this and just ignore this part here for now, and just treat this as we did in chapter 3, and we're just going to use the factor theorem to factor that. So we have to try different values. Let's try f of 1. Okay, so then we have 1 cubed minus 8 times 1 squared, which is just 8, minus 3 plus 90. Obviously, I can see that this is not equal to 0. So let's try, maybe a bigger number. Let's jump to f of 3. And let's try, this is going to be 3 cubed minus 8 times 3 squared, which is 9, minus 3 times 3, which is 9 again, plus 90. So we get 27 minus 72 minus 9 plus 90. So that doesn't give us 0 either. Okay, so now let's try another value. Let's try f of, say, 6. So 6 cubed minus 8 times 6 squared minus 3 times 6 plus 90. And let's just try that. So 6 to the power of 3 minus 8 times 36 minus 18 plus 90, and we see that gives us 0. Okay, great. So that means we can stop there. So that means if f of 6 gives us 0, the remainder theorem tells us, or the factor theorem tells us, therefore x minus 6 is a factor. Okay, so that means we can take this whole section here, so I'm just going to write this here, this whole part here, and so we can say all of that is equal to x minus 6 times something else. Okay, so we need to figure out what that something else is. X minus 6 times what will give me this original. So that's where our synthetic division now comes in handy. So I'm going to scroll down here, and what we're going to do is we're going to set up our synthetic division and put a 6 here, and then of course we put our coefficients of our expression here. So we have 1, minus 8, minus 3, and 90, and then of course we bring down the first coefficient, 1. 1 times 6 gives me 6, and then we add these, so minus 2, and we add minus 8 plus 6 gives me negative 2. Negative 2 times 6 gives me negative 12. And then negative 12 plus negative 3 gives me negative 15. And negative 15 times 6 gives me negative 90. And negative 90 plus 90 gives me 0. Now this is important because this is your remainder. Okay, and our remainder has to work out to 0 because we are dividing here by x minus 6, which we have already determined is a factor. If it's a factor, of course, the remainder should be 0. So, if we don't get 0 here, either we made a mistake in our synthetic division, or we made a mistake up here when we incorrectly assumed that this was 0 when we calculated it here. But we did get 0, so now we know that x minus 6 is, in fact, we've confirmed it, that it is a factor. Okay, so now we were saying that this original expression is equal to x minus 6 times something. Well, that something is given by these values here, with, of course, the degree starting with 1 less than the degree of the original. The degree of the original is 3, so this one will be x squared. So now I can take that and say, okay, so this is x squared minus 2x minus 15. Okay, and so all of this is equal to this now. So we factored it a little bit. But now we can take this part here and factor that again. Okay, so if I take this and write this on the side, so x squared minus 2x minus 15, okay, we can factor that because it's a quadratic, and so we have to look for two numbers whose sum is equal to negative 2 and whose product is equal to negative 15. Okay, so what comes to mind are the numbers 5 and 3. Okay, but one of them has to be negative since the product is negative. And since the sum is negative, then the bigger one should be negative. So negative 5 times positive 3 gives me negative 15. And negative 5 plus 3 gives me negative 2. So this turns out to be factored to x minus 5 and then x plus 3. So this whole thing can be replaced by these two. So now if we take this and we write it again, completely factored, it's going to be equal to x minus 6, and then with the red parts, this whole thing can be written as x minus 5 and then x plus 3. Okay, so now we can see that this cannot be factored at all anymore. So that's the original. From here, we factored it once using synthetic division, okay, and we got it down to this. Then we could take the quadratic and factor that again, and now we've got it down to this. But now let's return to the original question, which is this whole thing being less than 0. So now we have to say, okay, let's go back to the blue for the original question. We've got x minus 6 times x minus 5 times x plus 3 is all less than 0. So we need to solve this inequality. So there's a couple of ways of doing this. Maybe the easiest and most straightforward way is to actually just draw a quick sketch of the graph. From chapter 3, we learned that we can graph easily when the polynomial is in factored form, which it is here. This is in factored form. So we can see this is a cubic, obviously, because there's 3 x's here being multiplied together. So this is a cubic, and there's a positive leading coefficient. So that means that the end behavior is going to be something like this and something like this. Okay, because that's what a positive leading coefficient for a cubic function will look like. Now we sketch the zeros. So there's going to be a 0 at negative 3, so there's negative 1, negative 2, and negative 3. So there's a 0 here. Then there's a 0 at 5, so 1, 2, 3, 4, 5. And there's another 0 at 6. Okay, now putting these zeros together with the end behaviors, which we have discovered, we should be able to draw a quick sketch of the graph. Okay, so it doesn't matter how high I go, because this point I'm just trying to figure out where am I above and below the x-axis, because where am I less than 0? So the parts of interest for me in this inequality, since it's less than 0, are these parts here. Okay, so now I just have to describe those parts in a way that makes sense. So my final answer, if this is actually, this is -3, this is 5, and this is 6. Okay, so where is the function less than 0? The function is less than 0 at x is less than -3, okay, comma. It's also less than 0 between 5 and 6. So between 5 and 6, it is also less than 0. So those are my two solution sets. Notice that I don't put equal to 0, equal to signs here. If I put equal to signs here, for example, at 5, the function is 0. Okay, not less than 0. So if this was an equal to sign, then maybe I would put equal signs there as well. But it's not. It's just less than. It's strictly less than. So therefore, I cannot include 5 and 6 in this. I just want to know where the function is below the x-axis. Okay, so this is the solution to all of that. Okay, so in this example, we've gone over a couple of sections here in the advanced functions curriculum. That's the final answer, by the way. First, we've spoken about actually factoring a polynomial. Okay, so factoring a polynomial using the factor theorem, which we did up here, and then using the synthetic division, is in sections 3.5 and 3.6, and then solving the inequality, which we did down here in the last step, is section 4.2. Okay, so all of these sections put together are covered in this one example. Now, this was one method of solving this problem. This was the graphical method. There's also another method where you can use a table. If you use a table and you use your zeros, which are gathered from here, you can then choose values in those ranges and figure out if they're positive or negative. If they're positive, then you know that they're greater than 0, so they're not part of our solution. If they're negative, then they are part of our solution because they're less than 0. So that's another method that we can do. I'm not going to do it here because it will take a little bit of time, but yes, just know that there are other methods of solving this inequality. Okay, I hope you understood that, and I'll see you next time.